perpendicular lines. We're going to start off by what they look like visually. Let's start off with parallel lines. So I've got a line here, and I'm going to draw a line which is parallel to this line. So here we've got two lines which are parallel. And one thing you'll notice is they should never meet. They're moving in the same direction. They're not turning, so they will never eventually meet. And the key thing about them is they have the same gradient. Of course, gradient refers to steepness, and they're moving with the same steepness, so same gradient. Now I'm going to add a line which is perpendicular to the line I've drawn first. So here we've got two perpendicular lines. And what makes them perpendicular is the angle they make between each other. It's a right angle. Now that we've looked at it visually, we're going to look at it in terms of the equations. So this time the line we've got has got an equation, and it's y equals 2x plus 3. And the key thing is the gradient, which is the 2. That tells us how steep it is. The plus 3 is not important in this case, and as you know from equations of a line, if you haven't done it already, please go back and watch the video on equations of a line. And that plus 3 is just the y-intercept, where it crosses in the y-axis. Okay, so back to gradients. So parallel lines always have the same gradient, because remember, gradient is to do with steepness, and they're of course going to have the same steepness. So here you can see our second line has got the same gradient. Different y-intercept, but same gradient. So when we're talking about parallel lines, the only thing we're concerned is that they've got the same gradient. The y-intercept could be any value. So here we've got a second line, and this line is perpendicular to a first line. And we need to pay attention to the gradients. The key part is the gradients. Of course, we mentioned as before, they make a right angle triangle. What you'll find is if you multiply the gradients, you get a number. And that number is always the case with all perpendicular lines. You always get -1. So multiplying the gradients together, 2 times -1/2, one of those are minus, so of course it's going to be a minus answer, and you'll get -1. So let's look at a few lines which are perpendicular. So let's look at these two equations. Are these two lines perpendicular? So we're going to check by multiplying their gradients. And we do get that -1 we're looking for. So indeed, these lines are perpendicular. Okay, so here we've got a line L1, which has the equation y equals 2x minus 1. Of course, you should know the gradient is 2 in that case. And we ought to find out another line, L2, which is parallel to our line L1, but it passes through the point 719. And that 719 is going to come into play when we're trying to work out our y-intercept, that plus c from the y equals mx plus c. Okay, to begin with, we'll just say our equation is going to be y equals mx plus c, as all straight lines have that format. Now, since we know that the parallel, we know the gradients are the same. So what is L1's gradient? It's the number in front of the x, which is 2. And of course, they're parallel, so our equation will also have a gradient of 2. And you should know from before that m refers to the gradient, so we can fill in the m now. Okay, so we've managed to fill in the m, but we didn't know the c. So I've written out y equals 2x plus c, just for that one mark. Now, how do we get the c? This is where that coordinate they mentioned comes into play. We know our line goes through 719, so we can fill that in, and hopefully we can work out that plus c. So in our coordinate, the y value is 19 and the x value is 7. So it'll be 19 equals, and remember that 2x means 2 times x. Okay, so you can see here I put the x in a 7. The brackets does mean a times, and rearranging gives us, so now we've got the whole equation. So now that we've done a question which involved parallel lines, let's look at a question which looks at perpendicular lines. Okay, so here we've got another question, and it's not the same question. The main difference is this time we're working with perpendicular. So we've got our line L1, and we ought to find out an equation of a line L2, which is perpendicular to our line and passes through the point 6, 8. And the key word is perpendicular. So it's not like parallel where the gradient's going to be the same. So how do we work out that gradient? Of course, we know the answer is going to be in the form y equals mx plus c, as with all lines. How do we get the m? So we need to think of a number which multiplies to the 2 and makes minus 1. And the easiest way to do that is look at the number 2 as a fraction. And what would 2 be as a fraction? It'd be 2 over 1. And what you want to do to convert it is flip it. Get the reciprocal of it, which is 1 over 2. And also adjust the sign. So at the moment, 2 is positive. So we're going to make our answer negative. And we've got it. This is the gradient, which will be perpendicular to the gradient of L1, which is 2. The gradient of our line L2 is going to be minus a half. So we don't know the c value, so I've written plus c. But we've got the gradient in there. And if this was in your exam, you probably would have already got a mark for working out the gradient. So it's very easy to work out the gradient of perpendicular lines. You take your gradient and you flip it upside down and you change the sign. It's as simple as that. Okay, so how are we going to work out the c? We're going to throw that coordinate which our line L2 will pass through into our equation, which is 6, 8. So the 8 is the y and the 6 is the x. Let's go ahead and do that. So there we have our equation L2, y equals minus half x plus 11. Okay, so here we have to work out the equation of line P. And we can clearly see it's perpendicular to the other line which we have the equation of, which is y equals minus a fifth x plus 2. Okay, since they're perpendicular, we can work out the gradient. So we're going to take that gradient of the other line, which is minus 1 over 5. We're going to flip the fraction, which will make it 5 over 1, which is just 5, of course, and change the sign, so it'll be positive now. So the gradient of line P will be 5. Now for the C. As you can see, they both have the same y-intercept. So the C value will simply be the same. It will just be 2 again. And there we have it. I hope you found that video useful. Support us by liking, subscribing, and share this with your friends. And if you still got some more questions on anything, drop a post on our forum at examqa.com where you'll find your questions answered.